Great. Sean, do you want to take it away?
Yeah, so the first item, I guess there's not really much to show, but I figured I'd mention it. So I added a bunch more service pages to someone. Reporting have to private through them. So before we had CI runners, Italy, Postgres, and everything else. Sorry, and Redis and everything else. I've added API GitLab, which is a massive page that spans all the components across all of them. Customer stock, Italy, prefect, sidekick, and stuff. We could add more. Those are just the ones I added for now. This does mean the pipeline takes longer to build. Probably we were looking at that a little bit earlier, but yeah. These will have more predictable URLs now. And the other thing I added was something so that, so you know, we already have links in issues, and sorry, let me get this right. We have capacity planning issues. So this one would be an example, and they link to a page, and they link to an anchor on that page. So Bob and I noticed that when we move the pages around, the alerts change because the alert includes the page name and the section on the page it's on. So we've changed that now so the alert doesn't include this, but the problem is the alert can no longer template in the page name because it doesn't have a page name. So when we move something across the page now, that won't do anything. So what instead we do is we just always link to the intro page, and then there's a JavaScript redirect on there that knows where every component is on every page. So we can always just link to the intro page and that'll go to the right place.
That's very clever.
Better living through JavaScript.
Yeah. I have done 2 JavaScript client-side redirect MRs, one in the product and one in Tamland now for this sort of stuff, because before in Tamland, if you went to this page, but you weren't logged in, it would lose the anchor, and some of these pages can be quite long, and now it keeps it. So this is apparently my specialism as it stands.
Did you fix that in GitLab?
Yeah.
Sean, you are my hero. Thank you for that. Do you know how many things that messes up for me? Thank you.
Yeah, you're welcome. So yeah, that's that one. There's new pages. The second one I had was this MR that I just created. So it's not actually done yet, but this is an example actually. So this is not the correct saturation forecasting for this. This is me running a local thing and then grabbing those files to use as CI artifacts to pretend it was, and then there's this bot that can update that and add the image. So I spent a lot of time on this, and Bob convinced me that we could just do it a simpler way. So I can't figure out a way to make this fig.show just returns a stream of bytes, and those go into the IPython notebook, and then something, I don't know whether it's IPython or Sphinx or Jupyter Book or something else, gives that a file name of something like, but in this case, it would be sidekick_3_3.svg. So we don't know what, what that means easily. So one thing I thought was we could pass the HTML for the pages, but Bob was like, why don't we just write, we can write the image to a well-known file name, and that won't be used in the pages site at all, but we can just do that and then put it in the artifacts as well. It'll be zipped, so it shouldn't really add much to the artifact storage because it's exactly the same file, just in a well-known place. And then those end up in the book directory, so we just move them to the images directory, so they end up in the artifacts afterwards. Then this job downloads the artifacts, unzips them, runs this script against them. This script gets all the open issues on the capacity planning project, tries to find a matching file in the directory. If it can, it uploads it, and then it tries to replace the first image reference in the description with the new one, or just add it to the end and then update it. So that's not actually done yet because the prerequisite isn't done, because the prerequisite has another prerequisite that I need to go fix. And I also need Bob to review them, but hopefully somebody can finish those off while I'm away, and that can automatically attach those images in future. So yeah, that should make that easy.
There was a surprising amount of work to get images in the issues.
Well, it wasn't like, this wasn't a huge amount of work. It was just I spent a huge amount of time trying to figure out how to do it the other way. And I still don't know how to do it the other way. And now I'm doing it a much simpler way. So
Bob, are you going to be able to pick that up in Sean's absence? You're talking, it looks like you're talking, but there we go, it's working now.
Wait. Can you hear me?
Yeah.
Okay. The cable wasn't plugged in, or the button, or I don't know. No, I should be able to pick that up. And sorry, Sean, I didn't review stuff. I thought I was on top of things, but apparently I am not.
well, no, I've created a lot of MRs in the last 48 hours. So Andrew got some, you got some. I'm just like, let me dump all of this here and then take a month and a
Bye all.
bit off. Yeah, see ya.
Did you end up?
That is, but sorry, Bob. I was just going to say, I really like that as a really nice, simple solution. But also, when I saw it, it was like, I'm sure our days of Jupyter Book are slowly getting shorter and shorter, because basically we're starting to do everything that Jupyter Book does ourselves, and there's not really much left for Jupyter Book to do.
Yeah, we did talk about this yesterday. So you said the only requirement of this project initially was
that it was Jupyter Book, well, Jupyter Notebooks. That was,
but right now we're saying
requirements.
right now we've added a build step to build the notebook files, because like managing them manually is a pain, and we could do that all, like we could do all the rendering ourselves really if we wanted. So yeah,
we're no longer really relying on it to do the render either. So it's just a shell.
Well, wasn't it the intention to be able to render, like to use the GitLab feature? And
that was the only reason the project was created, was to run Jupyter Books, Jupyter Notebooks.
If I saw it correctly, the SVGs are too big, so they wouldn't render for us, would they? There's a limit somewhere for rendering, because that caused problems. I would need to check the But
we could just use PNGs as well, right? We don't have to use SVGs.
Yeah, but it's the amount of data. The thing stops rendering at some point.
Oh, you mean in GitLab Pages?
No, that's evaluated. No, the thing is evaluated to be able to look at like IPython files.
Oh, right.
Like in GitLab, and that was not the thing that we were supposed to use. No,
so the feature that we've used was removed because it was not really a feature. It was basically a Helm chart that created a Jupyter notebook in your connected Kubernetes cluster, and that was the feature. So I don't know, after that, there's no, I think it's been removed. It's no longer actually part of the product.
But now we have it in a notebook. It works. That notebook
also, the way the project works is you never interact with the notebook.
No, well, no, you built that we never need to interact with the notebook, but the notebook does much more than generating pages.
Yeah, it can do, yeah.
We just know
the end result. Yeah, but the end result we have is a GitLab Pages site. That's why we don't interact with the notebook, because we use the Pages
Yes,
site.
But you're moving everything that we need to interact with that into the issue board, slowly. Next thing, as soon as we get the images in there, we're going to maybe ask for the URL, the proper Grafana URL, to see the detail, and then
Maybe you'll come
we can
back to a
almost
whole
certainly do that.
different system after Printly.
I don't think, I think we'll always want to have the long-term graph in the issue, because it's always going to take a long time to render a year's worth of data,
definitely.
right?
Definitely,
Yeah.
but then like to see, so which part of this is saturated and which one isn't, you need to go to the higher detail ones anyway. So we need the link and we need the long-term, the forecasting.
Well, moving on to the next item in the agenda, I don't see Jakob on the call, unless he's silent somewhere. So Bob, do you want to talk us through the Redis cache analysis?
Sure. Let me open up. So TTL versus idle time first, because that's a new one. This table shows how much of the data is stored and what TTL it has left at the time of the snapshot. So the snapshot was just a scan and a dump of idle time, size, yeah, that kind of stuff. We can see that size-wise, most of the things live here in the 13 days. This is because of the default 2 weeks expiry that we have. And in the 0, that's things that people manually set a shorter expiry. So that's good, basically. And then we have some here in the middle because that's people setting a week as an expiry. But then this is quite interesting. We see that 90% of the keys stored in Redis have been idle for less than a day, and everything else is like not that much. So that makes me think that we're just constantly evicting. We never get keys that live for longer than like a day, and this is like, all of this is negligible because Redis randomly picks what to expire, what to evict. So
right, so we're relying on eviction as opposed to expiry, which
yes,
yeah, that doesn't surprise me too much, but
no,
it's nice to have the data.
no, but I was hoping that the spread would be more across, and we could say like, let's cut off a week and save like a week worth of data that we're not accessing that often anymore. But shaving off a week of the default expiry time isn't going to make a difference, according to this.
Yeah, so we would need to shave off some of the shorter lived TTLs to be even shorter than they are now.
Yes, or figure out a way to have more cache, because like in maybe I should run the experiment again for all of these, see what the idle time is and how many hours they are still active. Because then we could say like, these keys are taking a lot of space. We can there's an analysis with the tool that Jakob built last year that gives us like keys prefixes using a lot of space. I didn't see anything like super surprising in there.
The other thing that this doesn't tell us is how frequently these keys were accessed, right? It's only an LRU. So this is going to tell us, you know, it could be that a key was only accessed once, in which case we're actually wasting the cache space.
And likewise, the keys are being evicted anyway, so we're seeing the results of the eviction.
But we have metrics on the Git overview, I thought, of hit ratio, don't we?
I mean,
there was a
cache. That's not necessarily going to tell us anything about reuse.
No, but that's what we would need to watch if we shorten TTL and so on.
Yeah, exactly. So reducing TTL will reduce the hit ratio, and we don't know by how much. But since our goal is to just just get under the point where eviction is, where we're constantly driving the size of the cumulative size of the keys up towards the max memory boundary, we theoretically shouldn't be reducing the hit ratio if we get it to just a break-even point, because currently evictions are doing that for us by random key selection. Does that make sense?
Yeah, but wouldn't we need to like shorten the lifespan of quite a lot of keys in this?
Doing so for that 99% bucket seems like it makes sense.
Yeah,
or some portion thereof.
I think these things are already not being accessed, and they're just, that's what Redis expires, because that's how far it gets. Like, yeah.
Well, so like the selection is going to choose something like five keys and choose the one with the lowest time to live, if in fact it has a TTL set, which I hopefully is true for all of our keys.
Yes, almost.
Hash.
There's
Yeah,
like
great.
this much without the TTL.
Okay, great. So yeah, it should predominantly be choosing members of that low TTL bucket that you've got identified. The font's a little bit too small for me to read, but I think you said that the top bucket was 99% of the keys.
Yes.
Great. Okay.
Let me. I always zoom in by accident, and now I need to do it deliberately, and I can't.
No, it's okay. I'll follow up later. But the and I know we don't have to like solve this problem right now, but it seems sorry, go ahead.
The thing that I'm thinking is like some of the stuff that in there is like markdown cache and whatnot, and those things, like it's pretty valuable to have those live longer than a day, because like how often do you return to the same issue or something that you're looking at in markdown, like in the same day, and how many people do that?
Well, yes, that's true. So all right, so just rationalizing. Currently, we're getting an essentially random selection of with a pseudo random selection with a bias towards short-lived keys that get evicted, and we don't, and we currently are not exercising any control over that selection. The TTL adjustment gives us some control, so we can choose which particular types of keys get the reduced TTL potentially. So if there are particular keys, we could favor leaving a higher TTL on them, and that would implicitly bias, even if we don't get to the point where evictions are enforcing max memory. Even if we don't get to that point, reducing the TTL on something else so that there's a more attractive kind of victim key to be evicted would implicitly preserve those higher TTL keys in aggregate. So
with that, since we know that almost everything is in this 1 day idle, maximum 1 day idle time bucket, we just need to look at the keys that take up the most space, which is the second report, and see if they're like, it would make sense to lower TTL on one of on some of those.
Yeah, and even if it's not the largest keys, if it's the least valuable keys, I think that kind of makes sense. And we don't have to, like, the degree to which we need to lower TTL is really just to get ourselves to the point where growth doesn't exceed natural expiry, so that we don't naturally converge towards max memory, whatever max memory happens to be. This is the whole reason we can't just buy our way out of the problem, because whatever we set max memory to, that's what we'll hit.
Yeah.
Also, when we sort of used to have it bigger, and it gets kind of unmanageable, like when you need to start Redis again, and the snapshot times and the start times and everything start getting a bit scary. So I don't think we wanted it. I mean, the other option is we split Redis, we start splitting Redis cache, right?
That was my. The thing is, like right now, we don't know by how much we need to split it, because we can't figure that out. We're at max memory, but we don't know how much more Redis we need to add to not be at max memory.
I mean, it's not going to make things worse, right?
No, and we're going to have to do it eventually.
Yes.
I mean, the challenge also is like how much more effort we put into understanding what we're experiencing right now versus moving ahead with splitting out or making some kind of change like that. because we are seeing like pressure from the stage groups to try and figure it out. But I'm inclined to spend more time trying to understand exactly why this is happening.
I think we know why it is happening, but we haven't figured out what to do about it on the Redis side. Like if there's some config change or code optimization on the Redis side as well. Like Matt, correct me if I'm wrong here, but if we want to like do something to Redis itself to make this burst of evictions not cause clients to wait and or do less of them, or
so that's a whole separate topic, and Bob and I are going to chat in a couple of days to kind of explore our options and review the data. But in a nutshell, as far as I can tell, the on the topic of so we have, I think at this point we have a pretty thorough understanding of what's happening during these eviction bursts and why it's so impactful to Redis clients. Changing that behavior on the Redis side means making some difficult optimization trade-offs that would be good for our specific workload and horrible for other people's workload, and that makes it a hard sell to the upstream community. In kind of contemplating ways that we could frame this in terms of exposing it as a configurable optional behavior, personally, I haven't come up with anything yet that doesn't either require a really verbose explanation of how you would use this hypothetical new configuration to enable the behavior we're sketching versus, I guess what I'm really getting at is someone can, sorry, I'm kind of glossing over the behavior and I should just say what it is. So when there are three phases, so some of you will have already read this, so I'll keep this really brief. There are three phases to every time these eviction bursts happens. The first phase is the period before we reach max memory, and that typically lasts, somewhere between 15 and 20 minutes, depending on the time of day for our workload. The second phase is the actual eviction burst, and it lasts for something on the order of 6 to 8 seconds, again, depending on time of day. During that time, the clients, some aspect of the client workload, I'm going to go ahead and stop being strict about what's known and what's highly suggested by the data and just talk about what I think is going on. The incoming client request rate doesn't slack off initially, but the eviction bursts consume a large percentage of the Redis main thread's CPU time, and so client throughput drops enormously. By enormously, I mean somewhere on the order of 10x less throughput or more. So naturally, that means we accumulate a large backlog of clients. Incoming requests require memory, which continues to drive evictions further so that we can make room, because the buffers used for clients network IO, both incoming requests and outgoing responses, competes for the same pool of memory. So we have to kick keys out to make room for these incoming client requests, and that pattern continues until we have enough stalled clients that eviction can now, take kind of dominate the memory pressure and provide negative memory pressure for us. So that's phase two. Phase three is where the evictions have finally got to the point where enough clients are stalled, and enough clients are stalled that the request rate no longer exceeds the response rate. At that point, all the main thread gets to focus on sending responses out. All of the memory the memory that had been used for keys and was kicked out to make room for client buffers now can get rapidly freed because we're able to respond to those clients, and that is what causes phase three to have this precipitous memory drop over the course of about 20 to 30 seconds. And then we go back to phase one, where we're not saturated and we've reclaimed, say, 300, 400 megabytes worth of memory. That's the pattern. And to break that pattern, we either need to stop running ourselves into the ground or into the ceiling by hitting max memory, which is why we're talking about TTL, or we need to change the behavior so that when Redis hits some threshold like max memory, instead of really aggressively using CPU time to do evictions, it treats it more as a softer boundary so that we don't reduce client throughput as much during that phase, and hence don't get into that cycle of having to stall a majority of our clients so that we can, get out of phase 2. And that is a significant trade-off decision in terms of like Redis design, because it means max memory is no longer a guaranteed upper bound, and it makes it harder for people to plan capacity for their Redis systems, even harder than it already is. So this is why I think it's kind of a hard. I'm having a hard time justifying it to myself, so I can't really justify it to upstream community without, kind of putting some more safety parameters around it. So that's kind of where I'm at in terms of thinking about things we could do with community. The simpler thing to do is, like Bob's been describing, either reduce TTL so that we stop hitting the ceiling, or split the Redis cache cluster so that we, partition the problem and consequently don't have the same. I mean, the growth rate is like this. So if we partition the cluster, essentially the write rate of adding new keys has a much better chance of not exceeding the lifespan of the keys. So if we partition the cluster, we may not even need to reduce TTL. We may not have a persistently positive member pressure. Does that make sense? I'm going to stop yammering now.
when you were describing the problem that you want to solve on the Redis side, it makes me think like it doesn't sound like a feature that would be, yeah. But
it also sounds like something that would be surprising that we would be the ones to find something like this. Like I can't imagine that our usage is so unique that this isn't a known problem, or other people haven't run into it in the past. And
yeah,
and that also makes me hesitant to want to try and upstream anything for this, rather than just trying to try to partition it.
Yeah. So I think some of the core requirements to trigger this bad behavior is you need to have a high throughput so that we saturate CPU. Like we wouldn't be seeing this problem if our nominal workload didn't consume a large percent, like 75% CPU usage is very common on a before we even reach the peak of the workday. So that gives us at most 25% spare CPU time. The Redis 6 eviction model kind of introduced a new behavior that at least I and perhaps others initially thought was going to support kind of deferring evictions once you reach max memory, and it totally doesn't work that way. That was a misreading. There are two ways that evictions can be performed. One of the main way is every time a client request comes in, we call this function called perform evictions, and it will, if we haven't reached max memory yet, it short circuits and just returns immediately. And if we have reached, and it'll do something if we have reached max memory. How much CPU time it'll spend trying to get back under that threshold is configurable as of Redis 6, and we that's one of the tunables that Bob and I adjusted. And even setting it to its minimum value, it still completely destroys our throughput. I think we still had somewhere between 8 to 10x reduction in client request rate when setting it to the minimum value you can configure, which is, by the way, 50 microseconds per call. But our client throughput rate is like normally 20,000 calls per second. So that's an enormous amount of CPU time that we're spending on it, leaving very little left for processing client requests, which is why our throughput drops. So the second mechanism, the one that we were hoping would actually help us out, is this lazy evictions thing, where we'll say, okay, so we've burned the whole budget for one of these calls. Let's kick it over to be handled by. Let's schedule a task to run in Redis's internal cron-like behavior. That does happen, but it doesn't prevent the next client call from eating up the same 50 microseconds or 500 microseconds or whatever you have it configured for. So in our case, it doesn't help at all. It does help in cases where people have like infrequent client calls, because it guarantees that if you just jumped way above your max memory, you will eventually converge down because of this background. It's not really a background task, because of this periodic task. I didn't know that that's what the designers intended. So another pitch could be to say, have this this deferred eviction essentially act instead of the per client request code path. It has the same trade-off in terms of it makes max memory no longer a guaranteed upper bound to memory usage, and but at least it's leveraging an existing mechanism, and it would be a relatively small code change. But it's a significant semantic change in terms of how people use that tunable. So
it could potentially be both with separate thresholds, right? Like a low watermark for actual proactive cleaning.
Yep, that's exactly where I was going. Yep, totally agree. And that kind of puts that's what led me to, okay, how do you explain to someone how to tune these? And that's where I got stuck, kind of realizing that it's hard to explain the problem and how you should tune it for your own system, and because this is kind of niche in the sense that you're only going to run into the problem if you have a workload that consumes most of the main thread CPU and has a lot of clients and it has a growth rate that drives you towards max memory. If you don't have all three of those conditions, then you're not going to run into this, and people are going to be confused about how to set this. So anyway, I think
Memcached actually does this, like proactively scanning for basically doing eviction before you reach your max memory and doing that at a slower pace. Maybe a way of pitching it.
Sure, yeah.
Well, Bob and Matt, when are you meeting next week?
Tomorrow.
Tomorrow.
I think.
Well, can I please ask that when you do meet tomorrow, because I'm going to be out of office next week, if you can come up with like a clear path forward for what we're going to do, like have the conversations between, like, you know, the pros and cons for each alternative, but between the pair of you on the call tomorrow, please can you, the end of the call be, and this is what we're going to do about it, so that we can move forward with that.
I think I don't know, tell me if I'm wrong, anybody, but I think the inevitable conclusion is, like, at some point we're going to have to scale up Redis cache. Like, it's going to have to do that at some point. We don't know how yet. So
yeah, no, I agree. I mean, Rachel, so this is me putting firefighter hat on. First, you take it out of urgent mode, and the straightest forward path to that is adjusting the TTL. So we start with that, and as follow up, I think do the partitioning work is kind of where I'm at, and whether or not we contribute something to upstream is kind of ancillary at that point. We know that we have to do the second one. We have to do the partitioning because we know that our workload is going to continue to grow, and that gives us a long runway for whatever else the next phase is. Doing the TTL adjustments is assuming that it's not, that it doesn't turn out to be an expensive path, depending on I can't imagine it would be. Anyway, I think what we're expecting is that's the shortest path to get some results and get the stage teams unblocked.
Okay, and then in terms of like actually having to do the partitioning work, where does that fit into with the this is probably a question for Igor, but where does that fit in with the move to get everything into Kubernetes? Like, can we go ahead and do some of that partitioning now? Do we have to wait for a certain point in the other project?
Yeah, it's a good question, and I think a perfect timing to ask that question, because we're basically selecting right now and deciding which Redis instance we want to start with. So there is a table. You may have seen that table already. So we can maybe add additional Redis cache, like separate Redis cache instances. Not sure what we want to call those yet. Partitioned Redis cache, maybe. Yeah, maybe add that to the table, and And then we
Okay,
can
yes, please.
come up with an answer for that. I don't have one yet.
Okay.
John, is
Good.
the cross slot thing that you built last year, is that,
Mhm.
do we use that for Redis cache?
We do, but I don't think all uses are. I don't think we are compatible.
Rails.cache doesn't go through it, or?
Rails.cache, I don't think matters because you can't do anything multi-key in Rails cache, can you?
Don't think so, but like the uses of the Redis cache thing directly are like, you can count them. So
Yeah,
So
so
just
sorry, go ahead, Andrew.
no, I guess where you're going with that point, Bob, is that like at some point we have to get back on the Redis cluster horse, right? And you know, obviously it's scary to do that in an emergency, and like, oh, we don't want to do that, but that
we're going to do the
almost seems
TTL
like
thing for the emergency.
we have to exactly. So we have to start with something and maybe have like some small cache that we shard, or maybe that's the way to do it, is actually have like a small subsection that we break off as part of this like decomposition work. But instead of putting it into another Redis, yet another cache that's going to have the same problem, we put that small section into cluster so that we can at least start getting a feel for how cluster works.
Yeah, maybe I should like after we do the TTL thing, we can look into the direct uses of the Redis cache thing, if there are any offenses of the cross slot thing, or.
Yeah, Bob, sorry, I was wrong. You can use multi-commands with Rails cache, and we do already check it.
So if we haven't seen any problems with that, then we should be good.
But we have. I just linked to one. So all the known ones will be in that allow cross-slot commands thing if you rep for that.
But Sean, what we can do is maybe try, if we're going to petition something off as a next step anyway, we find something that we can petition off that isn't affected by the cross-slot problem, and
yes,
then
so
move
if we were
that
doing,
into a little cluster.
Yeah, so if we were doing rate limiting today, which we did partition off from the cache, then that would be a great candidate, because we partitioned that off, and we could have put that in a cluster, even though it's kind of unnecessary for it to be in a cluster just to try it out, but we already did that. So we need something.
What Igor and I were talking about in our call the other day was that one of the nice things about Redis, rate limiting, is in worst case scenario, if your cluster falls over, you can actually just let things pass. It's not a great solution, but it's, from the user's experience, there's no
downtime. If we lose
if
everything
you
on the
have
rate
a little
Redis.
Yeah, and so that's kind of a nice one to use for that, because like the worst case scenario would be sort of invisible to a user. Well, possibly.
Mm-hmm. Yes, no, I totally agree. That's the by far the friendliest one.
The worst thing that could happen is to us. So
exactly.
Bad guys get a bonus.
So can the newbie ask a really stupid question, which you're probably going to have the answer to? So you're talking about managing the TTLs and splitting. I assume there's a reason that vertical scaling is not an option, like making Redis bigger.
Yeah, so we sort of touched on it a little bit earlier. We used to have it at like, I can't remember, it was bigger already. So we had it at like, I want to say 100 gigs or somewhere like that. And we consciously brought it down because it was kind of scary during a replication fail. It was taking longer, and during startup, and during hello Amy, and during during a snapshot, like every snapshot was like a massive thing as well. So but we can also revisit that decision, right? Like if it's an emergency, we can.
That was kind of what I was thinking.
At the time. Yeah.
Like throw money at it is a very solid short-term solution. And it might be faster and easier than tweaking TTLs.
It's not really the money side of it, it's more the operational side of it. Yeah. But that's not to say that it's not something that should be on the table.
So the other reason that I kind of lean away from a vertical scaling is that the growth rate really is like shaped like that. So if we add, say, 30% headroom, I think that we'll just continue running into it.
Oh, no. I'm in absolutely no way suggesting that vertical scaling is a fix.
Oh,
I'm
yeah, no,
suggesting that it is an emergency option.
But
Sorry,
the,
I like
the
it.
emergency is like minutes apart. So
yeah,
Right,
this is on a
yeah.
minutes. This is on a tens of minutes time scale, not on a days or weeks.
Right.
Yeah.
It's one of those things that my question was just,
Yeah.
is that an option for short term? Obviously, from everything that you said, long terms, splitting it up in some fashion is going to be required.
Yeah, it's a very reasonable question. It's just we're dubious that it would help even in the short term because of the kind of the quirk of our workload. We're apparently really overloading. Like the number of keys we want to add far exceeds the retirement rates. Yeah.
But it's a good question though, because if we do both, like reduce TTL, we start by like reducing the global TTL of 2 weeks, so we never hit that. And then if we can get that saturation point, like of expiring idle keys somewhere around the 3-day mark, then we could work toward, like just set lower TTLs than 3 days. We would know that we could increase them, like vertically scale up that Redis instance a bit, and then we've got our emergency solution.
Absolutely. We don't know where the natural ceiling is because it's somewhere above where we're at now. So, yeah.
We're actually doing our meeting for Friday, Matt, because yeah.
True. Very true. Stephanie, if you're free, you're very welcome to join.
Oh, trust me, I would have invited myself, and I might invite myself anyways, but it is technically a holiday here.
Oh, I totally forgot. That's right. Canada. Right on.
But it's, I think, at a reasonable time in the morning, so I may jump on anyways. I went and looked at it's really nice. You two are fantastic. Anytime you're having a meeting is going to be a great time for me because the East Coast is the best.
Sweet.
We only got like 1 hour of overlap, so.
I know. It's right in my afternoon. Anyways.
Well, because I will be away next week, I just do still want to stress, if on that meeting you can make the decision as to these are the actions we're going to take, and then take the actions, whatever they are, just get on with starting them next week. Because I'm just hesitant to delay anything. Like, you don't need to wait for me to come back to, okay, just please get started with it. I trust whatever you decide to get on with.
Awesome. Thank you, Rachel.
Unfortunately, with that, I do need
priority set.
Yeah, thank you. But
Right.
Unfortunately, I do need to drop off the call, so I'll leave you to continue in my absence. I hope you chat to you all soon.
Oh my gosh, I love when Amy joins the call.
Matt, did you want to share anything more about instrumenting the binary?
So we're over time, aren't we? I can do this next time, or I can do it now. Whatever folks are interested in. I guess I'll go for it, and anyone that wants to can drop. Okay. Give me just a second. Okay, so I had intended to do a screen share, but I haven't had time to prepare like a proper demo of this. So I'm gonna kind of talk through some things, and if anyone wants to see more detail, just let me know. Okay, so what we really want to do here is I will screen share my notes though, just so we've got something to look at together. So okay, so interesting things about this. So what we essentially want to do is this is a snippet of Redis code. So this is the perform evictions function I talked about earlier. And as we can see, apart from initial variable setup, the very first thing it does is call get max memory state. And if max memory state is, so max memory state will do a couple of things. We're going to look at it in a moment. It will set mem reported is the accounting that J.E. Malik does to figure out how much memory J.E. Malik has allocated to various things in Redis through the zmalloc and friends functions. Mem to free is if our mem reported memory usage exceeds the max memory threshold, then this is essentially how much memory we need to free to get just barely back under that threshold after doing some exemption subtractions. If we don't have anything that we need to free, then this function will return okay, and we do nothing. This is the short circuit that I mentioned earlier in the call. So all right, without further ado, what we want to do is observe the variables that go into calculating this mem to free. And I've kind of extracted a portion of it. So up here, just for visual reference, we don't have to go into the details of this because I'm trying to keep it short, but the important bits are, for example, we want to find out what value gets returned here for mem reported, and we want to find out what value gets computed for mem used. After doing the overhead subtraction, it would also be interesting to see what this overhead calculation returns. So these are some of the variables that I wanted to get to observe. This is pursuing this was initially pursuing the idea of perhaps there's something unexpected going on with this overhead calculation that was causing us to overestimate how much memory we needed to free. And disproving that hypothesis led to other interesting things, which I would love to talk about, but for the interest of time, I'll kind of gloss over. So for this chat, we're just talking about doing the instrumentation of this particular function. And I want to point out that this function, this get max memory state, gets called in several other places. We specifically only want to instrument it when it gets called by perform evictions at this particular point. Okay, so those are the constraints. One of the interesting tidbits is we can how we do this. There are a couple of so before we dive into the assembly, I want to just mention that that at the point when we get to the what's the right way to describe this? So the constraint of only wanting to get this particular call point for this function, we handle that very differently if this call is inlined versus not inlined. Initially, I had a simpler implementation that dealt with it if if no inlining was happening, because that's the standard Redis build. Like if you do a make on the Redis source code, or if you use the Docker image that community builds for Redis, that has no inlining. When you build Redis by default, it uses a -02 argument to GCC, which doesn't include inlining. But when we build Redis as part of Omnibus, GitLab Omnibus, we override that to 03. And that does explicitly enable the GCC compiler to do inlining. And that this particular call site it's one of the places that does get inlines. So how in the world do you find that out? That's the first interesting thing I wanted to share. And I think I've got that in the notes here. But I wonder if it may be easier just to kind of show. So our Redis, you know what, maybe I'm going into too much detail already. So I'll just mention that I do need to show this though. So this is our Redis binary. And as you can see, it comes from Omnibus. It's under opt GitLab. And I want to mention here, because this is really crucial for this analysis, that not only is this binary not stripped, so it's got its debug symbols, it also has the new debug sections in it. And we can see that with, just I'll keep typoing for our binary. Oops. Oh, I'm sorry. We'll get to objdump later. I meant to type readelf. So yeah, so any of the elf sections that start with .debug are these debug sections that that the file output was showing us. In particular, this one is going to be super duper useful to us because this this particular section supports mapping assembly instructions to source code lines, which makes the binary analysis just incredibly simple by comparison. So when we do something like this, so objdump is, among other things, a free open source disassembler. And we're going to use it in that capacity. And we're going to say we want, what is your name? Keep forgetting. It's good for perform evictions. And this is our path. So this is what normal disassembly looks like. And I'm gonna, just for brevity, I'm gonna add just the text section. So this is the disassembly for this particular function. And if we specifically request line numbers, this gives us source code line annotation. And this is only possible because we specifically build Redis with the debug sections and don't strip them away. Otherwise, this option would have no effect. So this is absolutely fantastic. Oh, I'm sorry, I totally glossed over how do I know that we did inlining. So when I used perf to instrument get max memory state, it found 3 instrumentation points, not just 1. And I was like, wow, that's odd. I bet this means that we've got inlining and that we've got the debug info to unwind that inlining. If you don't have dwarf info, then the inlining is opaque. But because we do have our dwarf debug sections, the inlining is visible, and that's how it was able to find. Here's the main function, and also here are 3 points where it was inlined. And one of those 3 points was specifically this call from perform evictions to get max memory states at the particular source code line number that it cared about. So that's why we're here looking at the disassembly of perform evictions instead of just the disassembly of the call site. So I'm going to just highlight an example. Here's this line is in perform evictions, and this next set of instructions comes from get max memory state as of this particular source line. Just to kind of give you a feel for how we can walk around. So this is the call to zmalloc used memory that occurs on this line right here. You can see that because it's line 379 in evict. So we didn't have to do any kind of hard disassembly analysis. Because we have these symbols, and B, we have the debug section specifically for doing source code line annotations. So once we make this call to zmalloc used memory, we know that once we complete this call, the result value is going to be available in this particular register, and so we can read it. We can instrument this particular point after the call completes and read the value out of the register to find the return value of the function. That's essentially what we're doing in, just gonna look at this one as an example. That's essentially what we're doing in this BPF trace program. So, as an example, oh, this is actually the very example we were just looking at. So in BPF trace, you can define, so in this case, we're using uprobes because we're probing user space binary. And normally when you define a uprobe, you're going to specify a symbolic name for an address, like in this one, that shows us entries to the perform evictions function. But you can alternately specify a particular virtual address. And we have the correct virtual address from our disassembly analysis over here. So in this case, here's our zmalloc, and this is the virtual address that we would want to instrument. and then we'd pluck out the value of excuse me, gosh. Then we pluck out the value of either the register RAX or R12, depending on whether we're capturing the result value at this instruction or the next instruction. It doesn't really matter which one. There's once you get the result value from the function call, there's a few places you can pull it out of, and I think I was generally leaning towards getting it immediately after the function call, unless there was a particular reason not to. Okay, so that's the whirlwind tour of doing why we're doing instrumentation of the Redis binary at particular points, how we're finding the particular locations in the code section for where particular registers are going to have the right value, and from there it's I'm just going to stick with this example. We're pulling out the value from register AX and adding it to a hash map and composing a histogram with that value. In this case, it's a linear histogram with specific lower and upper bounds and interval because the powers of 2 histogram wasn't fine-grained enough. So in this case, I wanted a linear histogram instead of just a regular power of 2 histogram. And then if we're in debug mode, then we can print the, when I was developing this instrumentation, I wanted to be able to observe the specific values for each individual call. And so that's why I set up this global for debug mode. Okay, so that was the quickest I think I can do this. Any questions on this so far? I know we're over time, so.
Is this safe to run?
Oh, great question. Yes, I've run this in production several times. It is safe to run as long as we don't change the build of Redis that we're running. And that's why at the top, I noted a few ways you can check for this. So this is the Redis version string, and this is the build ID that we saw with file. And if you just, the easiest way to check it is this is the SHA-1 for the entire Redis binary. So we can do on, where are you? There you are. So the binary has not been upgraded yet or replaced yet. Yeah, I guess I just wanted to mention in passing that that we can do similar tricks in Kubernetes. There are some different moving parts. In particular, oh, right, like one important bit is I mentioned that depending on the compile time optimization settings that were used when building Redis, we may or may not have inlining. I fully expect that the Bitnami Redis image is not doing inlining because the upstream Redis doesn't. It uses O2 instead of O3. So in that case, we wouldn't use this program in that particular case because one, it's a different build, and so the virtual addresses will be different. We need to repeat the binary analysis to find the right instrumentation points, and two, we need to essentially deal with the fact that there are other call sites to this function.
We need to figure out how to ignore those.
Exactly.
Matt,
yes.
Two questions. The first one is, what happens if you put a uprobe and it's a different binary? And like, what's the worst case scenario?
Oh, fantastic. Yeah.
Yeah.
So,
what does it cause?
Sure. So you get garbage output, or you would get the just-in-time compiler would say, oh, no, I can't do this because, like, for example, there are various kinds of safety checks, but the arguably the most important one is this is specifically for BPF trace. If the so you don't have, by the way, you don't have to worry about this if you're using symbolic names, but if you're specifying particular virtual addresses and that doesn't represent an instruction boundary, then the BPF compiler will say, nope, I can't compile this. You're not on an instruction boundary. If you really, really want to issue the -- force, and good luck to you.
Which would probably almost never work because it just
Exactly.
and if it just so happened to be at an instruction boundary, right? So then
right.
it'll what would it affect the program or just the probe? Do you know what I mean?
Yeah, sure. So, so we're not modifying state for any of for any of the values. So the worst case scenario is, for example, if you were trying to instrument, I'm just making this up. If you were trying to instrument a function that had a low call frequency and you ran and the virtual address that you're instrumenting happens to be in the middle of a high frequency call, then you could amplify your overhead. I'm trying to think about what worst case outcomes would be. You wouldn't damage the data state, but
you wouldn't corrupt the program. Yeah, it would just, okay, that's really interesting. I love that walkthrough, by the way. Thank you.
Oh, thank you. So as a kind of a follow-on to that, I ended up like a few days later having found through that experimental results that some of the things that we talked about earlier in this call, I decided that I wanted to, let me switch back to, by the way, I can go into a lot more detail than this if anyone's interested, so just let me know. This is kind of a hobby, and it turned out to be really useful in this particular case. So one of the things I really wanted to find is during perform evictions, we knew that. So this is how I convinced myself that that how much eviction we were doing is not what's driving the memory usage. It's really is just a side effect of the stall, completely dependent of which keys get evicted. So to test this hypothesis, what I did is I instrumented essentially the same points in perform evictions because I'd already done the binary analysis to find that, and added latency to synthetic latency distribution to calls to this perform evictions prior to the point when we do this early escape shoot. So when we're not when we have not yet reached the max memory threshold, but then by definition we're never going to do evictions. And so I can synthetically, so while we're in that state, what I was calling phase one, that lasts for 15 to 20 minutes. While we're in that state, when we're for sure not doing evictions, I can synthetically inject latency into these perform eviction calls that mimics the latency distribution that we get when we are doing evictions. And to do that, I essentially use the same instrumentation point in BPF trace, synthetically made it burn CPU for a certain number of microseconds to emulate that latency distribution. And I got exactly the same pattern of memory usage shoots up, where we're doing nothing but essentially slowing down client throughput on this particular code path that gets called once per client request. So that was kind of empirical evidence that confirmed, that I think strongly confirmed that the stall by itself is what's driving up the memory usage, and that this supports the rest of the inference that it's the client workload coming in that's not being served in a timely fashion. So request rate exceeds response rate by a large amount, and Redis has to consume more memory to compensate for that. It doesn't tell us which areas are consuming memory, but we can draw some reasonable inferences from that. And we don't need to know which particular code paths are doing it to know that pattern is the crucial kind of yeah.
So the second question I have is sort of a little bit tangential, but like everyone else is using O2 on the Redis compile.
Yes.
Is there any background why we're using O3, or was it just like more optimized, like make it max? In which case, like, is that actually the right decision? Because if everyone's running with O2, shouldn't we just, because obviously it does, especially on something as critical as Redis, like it could change things, right?
Yeah, no, I totally agree. It looks like we're inheriting, I don't think we're doing it on purpose specifically for Redis. When I looked at our omnibus snippet that's doing the Redis build, if I recall right, this was a couple of weeks ago and I don't trust my memory, but as I recall, it's just being inherited as, kind of our generic GCC arguments rather than being specifically added. Like we specifically added
debug symbols.
Yeah.
Thank you. Yes, and no omit frame pointers. We specifically added that, but we didn't.
I understand why we added that, but O3 maybe it's just because O3 is better than O2, right?
I think so. Yeah. I'm glad you asked about this. I was kind of wondering that too, but I wasn't curious enough to.
Yeah. Okay, that's something to keep in mind. Thank you. That was a lovely, lovely demo as always.
Yay, awesome. Thanks. All right, that's probably all I got. I mean, again, if anyone's interested in more on this topic, I'm happy to share, but I feel like I've already kind of maybe gone a little further than folks would like.
No, super interesting.
Cool.
Thanks, Matt.
Alrighty.
Cool. Talk to you tomorrow.
All right.
Thanks, everyone. Bye.